Now we come to the page, starting with the title at the top, Traveling in a Lift. Now, when the lift leaves or reaches the ground, we feel heavier or lighter. Why? As we know, how heavy we feel and the reading of the weighing scale depends on the normal reaction. So it's normal reaction. And the normal reaction varies when the lift accelerates or decelerates. So we feel lighter or heavier. So we draw the force diagram of the man. Since we are focusing on him, the forces acting on him are the weight and the normal reaction supported by the scale or floor. Normal reaction. Okay, let's see. So maybe I draw the free body diagram first. Let me capture the screen and paste it here. So for this horse, the upward force on it is the normal reaction, okay, and the downward force on it is the weight. So I think they're the same. So this is the normal reaction. This is the weight. So suppose the weight is 600 Newton. 600 Newton. So by Newton's first law, as it moves up with constant speed, the upward force equals to the downward force, so the net force is 0. The same case applies when it moves down with constant speed. So these are the two diagrams, free body diagrams, for the first one and then the second one. Okay, let me scroll it down a little bit. So the first case, the net force must be 0 by Newton's first law. And the relation between the normal reaction is that they must be equal. So the feeling is normal. Okay, as 600 Newton. And the scale reading is also 600 Newton. Okay, now these 4 values must also apply to the case of moving down at constant speed. Now let's look at the more complicated situation, and the case of the lift accelerating upwards and decelerating upwards. Okay, maybe I can okay, so the first case we have 600 Newton. The weight is 600 Newton. For the second one, weight is also 600 Newton. Okay. However, when the lift is accelerating, the normal reaction must be greater. I use a thicker line. Must be greater than the weight. So say the for the first one, when it is accelerating, we put a number to illustrate it. So I choose 700 newtons. And then for the lift decelerating upwards, so the weight must be smaller. Maybe I use 500 newtons. Right, so these two are the free body diagrams. So the free body diagrams. Free body diagram. So let's make it smaller. Make it a bit smaller. Okay, let's look at it. In the first case, acceleration is upwards. Okay, and the net force must be upwards in order to produce an upward acceleration. And the relation between the normal reaction and the weight is that the normal reaction must be greater than the weight, and the feeling is heavier because R is equal to 700, larger than normal, and the scale reading is 700. Okay, now for the other case, when the lift is moving up, decelerating, the acceleration is downwards. So is the net force must be downward. So therefore, the relationship between R and W is that the weight must be greater than the normal reaction to produce a downward net force. So the feeling is that it's lighter because the normal reaction, normally it is 600, but now it's only 500, smaller than the weight. And the scale reading is 500. Let's take a